The International Space Station, or ISS, is a marvel of human ingenuity, a laboratory and home orbiting Earth at 17,500 miles per hour. Imagine a structure as long as a football field, circling the planet every 90 minutes, where astronauts from many nations live and work together. For over 2 decades, it's been continuously inhabited, a testament to what we can achieve when we unite for a common goal. The ISS is a unique platform for science impossible on Earth, from studying microgravity's effects on the human body to breakthroughs in medicine and technology. Every experiment pushes the boundaries of our understanding and prepares us for future missions to the Moon, Mars, and beyond. More than a research lab, the ISS is a symbol of international cooperation. 5 space agencies, 15 countries, and former rivals working side by side. From its windows, astronauts see Earth as a single, fragile entity, reinforcing our shared responsibility to protect it. The ISS inspires a new generation to look up and wonder what's possible. It's not just advanced engineering, it's a place that teaches us about our place in the universe and our duty to one another. Building the ISS was like assembling a life-sustaining puzzle in orbit, piece by piece, over more than a decade. It began in 1998 with the Russian Zarya module, soon joined by the American Unity module, marking the station's birth. Assembly required a dance between robotic arms and astronauts on spacewalks, with massive components delivered by the Space Shuttle. Canadarm2, the station's robotic arm, would carefully maneuver new modules into place, a process demanding precision and teamwork. Astronauts in bulky suits braved the vacuum of space to connect cables, bolt modules, and install equipment, every move deliberate and crucial. Dropping a tool could create dangerous debris, so every action mattered. Over 40 assembly flights and 160 spacewalks, the ISS took shape. Japan's Kibo Lab, Europe's Columbus, and multiple Russian modules all fitting together perfectly. Each addition expanded the station's capabilities, a testament to global coordination and engineering. The result, a sprawling complex with the volume of a Boeing 747, built by the world's best minds in peaceful pursuit. The ISS stands as proof of what's possible when nations unite for a shared vision. It's a castle in the sky, built by humanity, for humanity. Even in space, things break, and repairs can mean the difference between life and death. In 2007, a torn solar array threatened the ISS's power supply. Astronaut Scott Parazynski faced a dangerous spacewalk to fix it. The tear was far from the station, beyond the reach of the robotic arm. And the array was still partially energized. A lethal risk. The team improvised, attaching the shuttle's inspection boom to the robotic arm, creating a makeshift extension. Scott rode this flexible boom, venturing further from the station than anyone before, to install homemade cufflinks that stitched the tier. Working with bulky gloves, he avoided live wires and performed delicate repairs with Earth spinning below. The fix worked. The array unfurled, restoring power and proving the value of ingenuity and teamwork. This legendary spacewalk showed that, even millions of miles from help, humans can solve the unthinkable. It was a triumph of preparation, courage, and improvisation. The ISS is a self-contained world, kept alive by complex systems. Its lifeblood is electricity, generated by 8 massive solar arrays and stored in batteries for use during the station's night. Canadarm2 and Dextra, the station's robotic arms, handle construction, maintenance, and capture of visiting cargo vehicles, extending the crew's reach. The propulsion system keeps the ISS in orbit, using thrusters and gyroscopes to maintain altitude and orientation. The Environmental Control and Life Support System, or ECLSS, makes the station habitable, generating oxygen, removing carbon dioxide, and recycling water from every possible source. This closed-loop system reduces the need for resupply from Earth and keeps the crew safe. Temperature and pressure are carefully controlled, creating a comfortable environment in the vacuum of space. These systems turn metal modules into a home, allowing humans to live and work in orbit for months at a time. The ISS is a living machine, its heart beating quietly above our world. The ISS is the ultimate symbol of international cooperation, born from the end of the Cold War and built by 5 space agencies representing 15 countries. The station is divided into Russian and US segments, with modules from Europe, Japan, and Canada integrated throughout. Crews are intentionally international. Americans, Russians, Europeans, Japanese, and Canadians living and working together. English and Russian are the official languages, fostering camaraderie and mutual dependence. Cargo and crew arrive via a global fleet. Russian Soyuz and Progress, American Dragon and Cygnus, and more. Mission Control is a worldwide network with centers in Houston, Moscow, Munich, and Tsukuba, ensuring 24/7 support. The partnership has weathered political tensions, proving that science and exploration can transcend earthly disputes. The ISS model will be vital for future missions to the Moon and Mars, endeavors too complex for any one nation. The station is a global village in orbit, reflecting humanity at its best. It's a blueprint for what we can achieve together. Building and operating the ISS has tested human resolve and engineering skill at every turn. Connecting modules from different countries required unprecedented coordination and standardization. The station faces constant threats: micrometeoroids, debris, extreme temperatures and material degradation. Breakdowns, like coolant leaks or computer failures, demand quick thinking and custom repairs, often with improvised tools. The loss of Space Shuttle Columbia in 2003 was a turning point, grounding the fleet and leaving the ISS incomplete and under-supported. For 2 years, a reduced crew kept the station alive with only Russian vehicles, proving the strength of international partnership. Emergencies, like fire alarms or pressure leaks, are met with calm, practiced responses thanks to rigorous training. Each challenge, big or small, is a testament to the resilience and adaptability of the crew and ground teams. The ISS's survival is not just about fixing machines, it's about the indomitable human spirit. In the harshest environment, we endure and thrive. The ISS's mission will one day end, as decades in space take their toll. Plans call for continued science until around 2030, then a carefully controlled deorbit. Engineers will guide the station into a remote part of the South Pacific, ensuring debris falls safely away from people. Most of the ISS will burn up in the atmosphere, with only a few dense parts reaching the ocean. Its end will be a poignant moment, but not a failure. Just the natural conclusion to a historic mission. The ISS's legacy is in the science, technology, and global partnership it created. It taught us how to live and work in space, and inspired millions. The ISS stands as humanity's greatest engineering feat, a symbol of what we can achieve when we reach for the stars together.